Hi folks, I'm going to try to do one of the WebAssign questions. I'm also using this as an opportunity to test my AV setup here for both doing things on a whiteboard, audio, video. So bear with me if things are a little bit less than smooth this first time around. Today I want to do, I think, problem 8 from assignment 5.6 in WebAssign. So I'll take a look at that. So here we have the price of a commodity modeled by an exponential function, f of t equals 3 plus 2e to the negative 2t. Again, your problem will vary a little bit in the coefficients and constants that you encounter, but the format of the problem should be the same. You've probably seen a bunch like this already. Part A asks us about increasing or decreasing behavior. Part B about concavity. Part C about the limit of our function as t approaches infinity. And part D, asking us to sketch the graph, or at least to identify from 4 options what the graph of this function might look like. So let's start by taking a look here at part A that asks about increasing, decreasing behavior. So for any function, including exponentials, if we're ever asked about when the function increases or decreases, we should be thinking about the first derivative. Of course, when the first derivative is positive, our original function increases, and when the first derivative is negative, it decreases. So let's start by taking f prime of t. So f prime of t, term by term, derivative of 3 is 0. By the constant multiple rule, we can factor out a 2 from our exponential part. And then the derivative of e to the negative 2t is e to the negative 2t times the derivative of the exponent here by the chain rule. So we'll have e to the negative 2t times negative 2. And simplified, what that would give us then is negative 4e to the negative 2t. Now we want to know when the function increases, when it decreases, and so we want to know when this first derivative is positive or negative. One thing we know about all exponential functions, exponential growth or exponential decay, is that they're always positive. So this e to the negative 2t, it's always going to be a positive term regardless of our input t. Negative 4 is obviously a negative number. If we multiply a negative times a positive, we'll always get a negative number, telling us that that first derivative is always less than 0. So if our first derivative is less than 0, that means the function f is always decreasing. Okay, part B asks us about concavity of the function. Concavity, of course, is given by the second derivative. Again, when the second derivative is positive, we have upward concavity. When the second derivative is negative, we have downward concavity. So we've just calculated f prime of t up here. So let's calculate f double prime of t just by taking the derivative of f prime. And so the derivative of f prime, here's f prime, negative 4e to the negative 2t. Constant multiple rule, keep the negative 4. Derivative of e to the negative 2t, we just did this, is e to the negative 2t times an additional term of negative 2. So again, when we simplify this, negative 4 times negative 2 is 8. And so we have 8e to the negative 2t for our second derivative. Again, the exponential part always positive, and the number 8 is also positive. And so the result for our second derivative then must always be greater than 0. And so our function f is always concave up. Okay, so hopefully that makes sense. Hopefully you can see my full work on the whiteboard here. I'll just adjust it a little bit, so maybe if you missed that bottom part. Okay, let's take a look back at the original problem, see about parts C and D. I'm also going to clean off my whiteboard here. So here we are back in WebAssign. I can input my answers right now. So I think we decided that since the first derivative is negative, the function is decreasing. Since the second derivative is positive, it's concave upward. Next 2 parts are to evaluate the limit of our function as t approaches infinity, and then finally to choose between 4 options as to which graph best represents it. Go back now to my whiteboard here. Okay, so here's our function, f of t, and in part C, we want to know the limit of our function as t approaches infinity. That is to say, what happens to this model as time goes on. So we're taking the limit of 3 plus 2e to the negative 2t. Now, the way I've shown to do this in the past is to sort of build outward from the innermost part of the function, from that variable t. I'm going to do the same thing, but I don't have a ton of space to work here, so I'm going to take it one step at a time. Here's what I'm going to do. I'm going to look one at a time at what happens to the variable t, and then as I build outward, I'll look at what happens to negative 2t, and then what happens to e to the negative 2t, and then what happens to 2e to the negative 2t, and finally what happens to 3 plus 2e to the negative 2t. So that is to say I'm going to build up my function f, starting with just our variable t and moving outward until we have the entire function here. So our limit tells us what happens to t. T approaches infinity. So I'll just write that down here in shorthand. T is headed to infinity, and so t times negative 2 would head to negative infinity, right? Positive number increasing multiplied by negative 2 will become negative numbers farther and farther from 0. Okay, next step. If I have an exponent that's approaching negative infinity, that's what I just figured out in the previous step, what happens to e raised to that power? Well, e to the x, as x approaches negative infinity, we could think of that as an exponential growth curve that we're following from right to left. What's happening to the y values? They're flattening out and getting closer and closer to 0. Another way to think about this is to think about the graph of the function y equals e to the negative x. Just our basic exponential decay function. Y equals e to the negative x, exponential decay, again, flattens out, gets closer and closer to 0 as we move to the right. So e to the negative 2t will approach 0. 2 times something that approaches 0 still approaches 0. And then in our final step here, we need to add 3 to our function. The rest of our function we just decided was getting closer to 0. And so if we add 3 to that, our limit will approach 3. And so that's our answer for part C, is that the limit of our function f as t approaches infinity is 3. Now, what that'll mean for our graph is that there'll be a horizontal asymptote as we head to the right. So we should be looking for a graph that gets closer and closer to the line y equals 3, the farther to the right we look on it. Okay, let's take a look at those graphs. So our options here for the graphs have 4 options here. So again, just to review, we've decided that the limit equals 3 as t approaches infinity. So a decreasing concave up function whose limit as t approaches infinity is 3. Well, I see 2 functions, the second and the third one, that are increasing. So we can eliminate those possibilities from the beginning. Between the first option and the last option, they're both decreasing functions. They're both concave up. And one of them, the first one, it appears it has a horizontal asymptote at y equals 2. And if we look at the tick marks here, our last option looks like it does indeed have a horizontal asymptote right at about y equals 3. And so that will be our best choice from the options that they've given us here. So hopefully that makes sense. Hopefully that's helpful in completing these problems. This problem follows a very common structure that you'll see on a bunch of the WebAssign problems. I'm planning to put a couple more up a little bit later on, as long as all of our technical issues work out. If you have any feedback for me as I make these videos, please let me know as soon as possible, and hopefully this will be helpful for homeworks.